Hello everyone. So today I'm going to teach you a very simple thing. Let's imagine that you have two power supplies and they're programmable and they feed power to their individual circuits. So let's just draw it really quickly. We have here power supply number 1 and 2. I'll just name them. This is 1, this is 2. Both of them, sorry, I meant 2. Eraser and here, this is 2. And these power supplies, basically, they can provide signals to their individual outputs. Don't mind my drawing, just roughly drawing here, and likewise this side. So these power supplies, they can provide signal to their respective outputs like this. And this one can give 10 watts, for example. This one. So basically, now we have here our KiCad program, and we have created a project, and we know here these are our basic requirements. I'm just going to write it up over here. Basic requirements. It's very important to write your basic requirements in the beginning of the program so that you won't lose your scope. So his basic requirements here we want to take 12 volts or 24 volts voltage input for our system, and we need to take 12 volts or 24 volts logic signals and a relay output. So from here, there are two ways to go. You can just start putting sample schematics and then selecting the components, or select the components, the main components like the voltage regulator and the logic gate and the relay, then come back to the system. So I'll go to the option 2, which is going to supplier. So I found this power supply here. As you can see, you can find them in multiple ranges, and it takes 4 volts input and output 36 volts DC, and it can output any range within this. So I've selected this one, which we are taking 6 volts input, minimum 6.5, and output to 5 volts. And this specific datasheet, they don't provide any sample circuit, because I believe inside this we already have all the capacitors and resistors required. So that will be our power supply regulator. So let's just add that. We put this on the side. We need our logic gate. So again, just went through LCSC and selected any searched for NAND gates, and I ended up selecting this one. It's pretty cheap. You can get 5 of them below $1, so that's pretty cheap. And here is our datasheet. Again, we need to look at the datasheet because we need to know what is the voltage limits on this A and B, and what is the voltage output on the logic gate. So here we can get the functional table, the function table. So basically our inputs here, it's A and B, and our output is Y. And we have power supply for the NAND gate. This is what we are looking for. So basically we want to notice when each of the contactors is on, the contactor of junction can be on. But if both contactors of the individual supplies are on, then junction contactor should not be on. So that's the case where A and B are both receiving high, and this should be low. Therefore, we need to make sure our relay goes off when the NAND gate goes low.
be patient, we're running out of time. No way I'd let you slip by. No way I'd let you say bye. You said there ain't no meaning, I just wanna understand everything that led us here, the teardrops when I hold your hand. No way I'd let you slip by. No way I'd let you say bye. Can we watch it fade away? Can we let it fade away? We'll take it day by day.
So basically now we have here everything connected, and I'll just go through the schematics and the idea. So basically we have here our connection input, where we will have here our A, our B inputs, and we have here our VCC and ground, 12 volts or 24 volts, and that is being fed to our voltage regulator, which will give us 5 volts at output. Very simple. And I just put here some bank capacitor of 1 UF. This board won't be consuming any power, so everything is gonna be low power, low current. So I just kept a small bank capacitor for redundancy. And we have here as well at the output, 5 volts output, a bank capacitor for the 5 volt rail, which that 5 volts is being fed to our relay positive, and then also being fed to our uh, NAND gate over here, as you can see. So our NAND gate can actually take up to 5.5, but I'm just giving 5 volts, which is pretty enough. And a decoupling capacitor. Again, to make it overkill, I have here some set of voltage dividers, because again I told our logic input should be anywhere in this range. So I did my voltage divide calculation, and if you do it by your own, you'll get this out. If 12 volts, this will give you around 2.5, and at 24 volts it will give you around 5 volts. And I kept such high values so that I will get less current flowing through this specific circuit. Okay, and that is pretty much it. And I've selected the footprints and everything. Now we should go to the PCB designing. Do our ERC, check everything is selected. We run our footprint, not footprint editor, sorry. We'll check if everything has footprints on. Just wait for that to load on. Let me close it. Just check if everything has footprint assigned. So we have this guy that its footprint is not assigned, so we just go through that. This footprint is same as this one, and this guy, the footprint did not come automatically. It's okay. Let's check here. Not the different footprint. TSR, that's what we have here. Select, okay, that's done. And we should have all footprints assigned. Yep, good to go. Go for PCB arrangement. So in our PCB, gonna make this most likely one layer PCB, but let's see how we go. I'm just gonna update here. It's a really simple circuit, so just give a large draft arrangement over here. Just let me look. Okay, Perfect. And we just hide everything that we don't need, and it will show exactly what we need. So here our input and our output. We keep the delay on that side, this also on this side, and we have here a small NAND gate. Okay, let's how I like to do this is let's select the input side first. We'll work with these components so it's easy to identify them. I'll keep these guys as close as possible to the input, and we'll keep this bank capacitor over here. Try to keep it like this. Maybe you should have placed the LED on this board. You can add that later. You can keep this capacitor anywhere actually, as long as it's close to this guy. I like keeping everything aligned, so I will align this with that one. Again, this is just a rough design, guys. So you see here, these guys are crossing. We don't want that. So what I'm gonna do is I'm just gonna switch these guys. It's gonna be a little bit ugly, but it is what it is. It's not a biggie. Just ensure that these two are not connected by any chance, which should not. And we update here. Now we can see that that is perfect. And now we can basically align these guys on the bottom side. Don't know why this moved also. Yeah, do this over here. I don't need to put these screens right now. Put this guy in the middle. Put this guys somewhat like. So guys, we have here the edge cut. We have the rough arrangement of everything. So what I'm gonna do is I am gonna fix the edge cut, and I'm gonna make everything else move. Like that, I can just start arranging everything. I'll give this some 2.5, then I'll come to the edge. I'm okay with this. I'll come to the edge, sort of. I'm okay with this, and I'll start moving everything inside accordingly. So I'll go 2.5, something like this. This is okay. I've routed everything, and I opted to not put any copper port because again it's not needed, pretty simple. Sometimes you don't need to put copper port. As you can see, everything was done in almost one layer, just few back layers we have over here. We have our 3D render here, my logo over there, and my logo over here. Let me know down in the comments how I did it and if you will approach this problem differently. Thank you.